that one LED that I had directly connected to plus 5 volt is extremely hot. Ow. This here is the module that we built yesterday. This is the first register module of our 8-bit computer. We haven't quite finished it. We need to do the LEDs here, and so that's kind of the plan for the stream here, to do the LEDs, and maybe we watch the next video as well. And a super nice person on my Patreon has messaged me a list with all the videos of this series by Ben Eder of building this, commented what is like coming up next without like spoilering, just to give me like an idea of what I have to do for the streams, something like this. So that was unexpected and amazing. And so in there it said that a couple of these register elements are built in the background, and so of the series that will be coming up. So I know that we will make a few of these starting, I guess, today in the stream, and then maybe the next 1 or 2 streams just building a couple of these. I think there were like 4 overall or something like that, but let's see. Oh, there's one other thing. Okay, before we get started. So as you can see, there are a lot of wires that we had to cut. And so I have an announcement for you. Let me change back to this camera here. Okay, wait. Everybody, pay attention. I have an announcement to make. Something incredible happened today. I was being let down by the delivery of tools that we need for the battle of the wires. So today, before the stream, I ventured out into the world, into the real world outside. I had to encounter people, other humans. I traveled in a carriage full of other humans. It was awful. I walked through the blazing sun to find the one tool that we need after being let down by the delivery people. But I couldn't wait any longer. So, here it is. A wire stripper. Finally, we can ditch the terrible clipper to strip the wires and destroy them. We have a wire stripper. This is gonna be amazing. Oh my gosh, I can't believe that I finally got it. I don't know if it is any good. It's not the one that I wanted to order online, but I think it will help us tremendously with the task that is ahead of the dozens and dozens of wires that we need to strip. I'm so happy. This was music by Alexander Nakarada, but Creative Commons with attribution license. So here's the attribution. Oh, god damn it, I'm so happy. I keep having to add stripper to the auto moderator because the auto moderator keeps deleting all the messages with stripper in it, but it is stupid. So it's like if somebody ends their sentence with like a dot, then it's like stripper dot. That's the sentence that's being censored, and just whitelisting stripper doesn't take care of that. So I need to whitelist stripper dot and stripper comma, and then people had like spelling mistakes, so it was stripper comma dot and stuff like that. Finally a wire stripper. So let's see how this goes. Trash can, and I need to put my light back where it belongs. So let's try out this wire stripper. Let's see if it does the job that we need it to do. I tested it just briefly in the store. I brought a spool of wire with me to the store, and then I tried it. The focus will probably screw us over, but let's see. There it is. What an amazing tool of engineering. And the wire doesn't, the core doesn't look damaged. So that seems fine. Whew. Magnificent. That's a great word. Okay, so here we have red LEDs. We need resistors for it as well. Let's see, what kind of resistors do we have here? It must be a pack with a lot of them. Oh, these are huge resistors. I think I bought kind of the wrong ones. Like, these are for probably way higher voltages. They are like massive. I might need to reorder those. See, these ones are smaller. These will be way too large for, like, it will look hideous on the breadboard. Let's see. Gold is on this side. So, crap, what color is this? Brown black. 1 0. No, it's brown black. Wait, how do I read this again? I thought I know how to read this. Or is this just a weird table? Brown, black, green. Brown, black, 1 0. No, wait. Yeah, let's measure with a multimeter. I thought I know how to read this thing. I'm a bit confused. I blame the heat. Let's blame the heat. Oh, it's a 1 meg. Wait, what color is 1 meg? Oh, is that a blue? That's not a blue. That's no, in no way is that a blue. I really like my new headphones. Now I have this long cable and I can like move around without having to put them off. Okay, I have like these kind of rolls that I bought at some point. I probably bought them for LEDs, so they... what headphones did you get? Those are the Sennheiser 660s. So here's something I learned recently. I didn't know like the difference between like open back headphones and normal headphones and all that stuff. I never realized that there's like a difference, or that there are like preferences or for different usage things. So I kept buying these terrible headsets or headphones or something like this. And then I stumbled over this concept of open back, or whatever it's called, headphones. And I decided to, a lot of people seem to like them. Let's buy a pair. And my mind is blown. They are so much more comfortable because they are open, so I can hear everything around me, like these cables clashing against the table, the clicking of my keyboard. I can hear everything, but I still have like headphones on and can hear whatever is on the computer sound. So I feel a lot less claustrophobic, or it feels like a lot more relaxed and stuff like this. I don't know, I had like this whole epiphany about headphones, and I'm such a huge fan of them now. This is 110. Open back is so got the nice normal hot ears. Yeah, right, that's another thing, that like the air gets to it, so it's not as sweaty and stuff like this. And you know, I have noise cancellation headphones as well. Like, I love to go outside with the noise cancellation headphones because I can drown out just the noise of the city, and I hate people, so it's like super nice. But for inside, when I'm here in my space and I want to hear my keyboard and maybe the dog is coming in and stuff like that, yeah. Yeah, noise cancellation is also awesome when you don't want to get distracted. For example, if I would work at an office with other people around me, then probably I would also wear the noise cancellation headphones. But my noise cancellation headphones also slowly get destroyed. I wear them so much. One of my best tech purchases ever, but look at that. That just happened like in the past few days. LED LED resistor calculator, 5 volts, voltage drop from LED, and then let's see, maybe it's here, 30 mA, max is 2.5 and 30 mA. So we have 30 mA, 2.5. If that would drop to 2, then we have 100 ohm. Okay, I can run this with 100 ohm. Okay, yeah, well then I can just use, I guess these here maybe, 120 ohm. So I guess we use these here, and maybe I replace these one up here too, because I think these were 220 volt, and they are quite dark in some way, compared especially to the blue LEDs. And maybe I want to put the blue LEDs even further down because they are so obnoxiously bright. Okay, Clipper, I know I hated on you earlier, but I need you now. Oh, there. Are you going to make a video about RAM bleed? I know you usually don't do videos on current ones, but this sounds pretty interesting to me. All these hardware vulnerabilities are super incredible, and I would love to make in principle, I would like to make videos about this. And I also would in principle like to make videos about current vulnerabilities. The problem is just a time issue, because usually I don't, like, when they come out, I don't have the time. And now specifically with like these things like RAM bleed, or even Rowhammer in the past, or what's it called, Melter spec down stuff. The problem is I want to do these videos properly. I don't want to just make a news video just reiterating what people can read on the official website. If anything, I would want to read the paper and really understand it and reproduce it and show it off and show something, you know. And so that would require me to dive deeper into the paper and all that stuff. And I haven't done that for any of these vulnerabilities. They are super interesting to me, but I don't know, I haven't, like, other stuff has just had always priority over it. But I definitely want to make videos about these kind of things at some point. And then I also don't think necessarily that it has to be a current vuln. Like, just like the principle of these attacks. Like, even just replicating Rowhammer or something like this is just really, really cool. But yeah, like I said, I would want to understand it a bit better and make a nice technical video about it and not just a high-level news video. Melter and Spec. You're right. Wait, what? It's Meltdown and Spectre. Clearly, I'm not qualified to make videos about them. I mean, he also, oh wait, I just realized. There are 3 registers. This is the A register, the sum register, and the B register, at least on this version here. I mean, we are free to build however we wanted to. But all 3 registers have stuff on the right. And on the original A registers, there's here enough space. But on this register here, there's basically no real space. I mean, you could put it all the way to the right, then you have a bit more space. But also here are the cables. So, yeah, so I'm not sure. Look, I don't like how kind of that they look like this. Let me check. I think I still have small LEDs here. Can somebody help me? I can't make a decision. Oh my gosh, this was a mistake. Okay, so what? Crap, I didn't even record what happened. I plugged in the red LED directly to the power rails because I thought, maybe they can handle it. And then they got very hot. Like, very hot. Okay, do it like Ben do it. That's a good idea. You're right. Let's follow Ben's videos. And then later, when we get a better picture of everything, we always have the choice to then iterate on it and modify it and change this, and maybe we want to change the LEDs. Oh, so Ben either managed to somehow have another row of free slots here, because we need to plug in on this rail here the positive of the LED, and there's like no space because I went up until here, and he saved that. He condensed these wires more to have space here for LEDs. The 4 previous streams were over 2 to 3 hours, so I guess we are at like 12 hours or so with this project. Wow, that's kind of a lot already, and we basically didn't do anything. Well, things always take more time than you initially think it will. Ah, crap. Well, here's the now if I start now here, it will slowly move further and further over there. Okay, wait, let's take that out for now, and let's first prepare a couple of LEDs before we plug them in. I don't know, the spacing is... Oh no, I guess it looks fine. Yeah, it's like not possible to have perfect spacing, but I guess this is actually good enough. That's pretty okay, right? I don't know, it would be nicer if they are all like nicely touching, a bit more condensed, but it's either too much and they push each other out of the way, or it looks a bit like wider like this. But I think this is good, right? How am I so bad at this? This was way too long. 13 degrees in Belgium. Oh my god, let me check the temperature here. It's 32 degrees, but outside it's 35. Is that correct? Or maybe my measurement is also in the sun right now, I'm not sure. Yeah, well, you can see it. My apartment is really bad because we get our apartment is like around the corner of the building, and this corner is pointing directly south, or wherever the sun is. Is the sun south? Ah, found it. And so we get sun all from the sun getting up until the sun goes down. The sun is just shining in our windows, which is nice, you know, daylight all day long, but it's so goddamn hot. And that's why we have we bought like these mobile AC units. They are inefficient and waste energy, but they make this place bearable in the summer. However, they are very loud, and so I don't want to run it while I'm streaming. Just buy a big ice cube from Norway and put it in your room. Bonus fresh water when it slowly melts. Transport logistics is just some paperwork. Do you got a company you can recommend? Okay, let's watch this video here.
Pin from high to low. So in other words, we're telling our...
Actually, maybe we kind of like pause because now he's testing. We could now test with him in the video. So let me also get this set up. Yeah, $250. I think I paid $240 for my initial delivery now, but I will probably reorder a couple of parts again. It also helps if you already have a little bit of electronic stuff at home, because you might need like an oscilloscope, you might need like a power source or something like that as well. So, you know, if you bootstrap from zero, it might be a little bit more difficult. But yeah, exactly. I don't think that the price is too terrible, especially for the learning experience that it provides. You know, this is like Lego. I love Lego. Lego is a great entertainment and a great toy to play with. So just imagine this to be a big, more expensive Lego package, but instead of like offering you 8 hours or 10 hours of building fun, it offers you weeks of building fun. Yeah, so it's like grown-up Legos. Obviously, I also can't count because these are 7. Okay, then we need to connect the ground rail. Okay, and then we need to connect here. This is like the enable or the output enable or something like this. I want to quickly check the data sheet again. what we plugged in there. Okay, so yeah, so 19 was put to VCC. That's correct. And down here we connected 1, 2, 3, 4, 5, 6, 7, 8. We connected pin 9. Where's pin 9? Connected 9 is the AI. What is that? Oh, in or out. Okay, I think I feel kind of confident to almost plug this in. What else do we need? We need to connect this to the clock output. Here, okay, moment of truth. Okay, no short circuit at least. Nothing has blown up. The ICs don't feel hot. Oh, wait. Like this, okay. Connected the clock and the power here.
Everything, all of our
what
bits
did he
in our
do? I
register
didn't
went
pay
high.
attention.
And you might wonder, next time the clock, when we bring our load pin from high to low. So in other words, we're telling our register to go ahead and load whatever's on the bus. So we see that when the next time the clock went high, everything, all of our bits in our register went high. And you might wonder, well, why is that happening?
It's not happening for me.
We see that when the next time the clock went high, everything, all of our bits in our register went high. And you might wonder, well, why is that happening? There's nothing on our bus. These are all off. Why would these come on? Well, because there's nothing on the bus. And so that's just what we're seeing, is we're seeing that, since there's nothing connected, they just show up as high. But what we can do is we can now
see what happens if I would actively put one to plus. So I connected it here. So we need the input. Something is wrong already because I connected this board. Wait, this board has no VCC connection. Ooh, okay, because the LED should turn on. Okay, so this LED is now on. The LED looks on. You are right, it's kind of dark. Okay, let's measure quickly the voltage on this LED here. Oh, there it reaches 4.2 volts. Wait, maybe these LEDs are glowing, they are just like super dark. These ones here are slightly glowing, do you see that? It doesn't seem to affect this. However, I'm not sure, you probably don't notice this on stream. Maybe you even notice. Do you notice how it's affected by the clock? How bright it goes? Okay, so output, did you notice this? If I disable the output, it's not outputting anything. That one LED that I had directly connected to plus 5 volt is extremely hot. Ow. So the clock we are getting is 3 volt. I mean, my thing is, wait, let's go to manual clock. So this is the 0 clock, and this is the on clock with the 3. Maybe you're right with the LEDs. Let me disconnect this LED and this LED. Wow! Yes, and it looks like it's powered, but works so too much voltage drop over the boards. Okay, so this board, so right here, when the wires are coming in, I'm measuring 4.9 on this board. I'm also measuring 4.9, still here, and on this board then 4.9. But see how it crazy it dropped? It was 4.98, then here it was 4.95, and then over here it's 4.99. Put the input current to the other board. Okay, let's put it over here. I short circuit them. Good job. So if I only see these LEDs on when the registers are input enabled. If the input is not enabled, like this. Now, this is also because the output right now here is, but the output is also enabled by GND, but right now it's on VCC. And now everything is dark. Oh my god. So all of these look properly connected. Okay, let's measure the power connection on all of the chips really quick. Have you connected two grounds on the middle board? Connected the two grounds. They are on this side. So pin 8 is GND. On the registers, it's bottom left, and you see here a... Oh my god! The same mistake. I did the same mistake already before. The same mistake. Thanks, Moocher. The same mistake. I forgot this with the other board too. I need to connect the other rail. Look at this. Now they are shining. How is it supposed to work? We enable the input, and when the clock comes, it should be stored. So these LEDs are also not working right now, right? That makes total sense because I connected them wrong. I connected them all to VCC and they need to be connected to ground. Okay. Now they are also glowing and are on. Okay, so now let's think. We enable the input. By the way, just to boost my ego, the problem was discovered via a Pixel 2 screen I have about window to look at cables. Nice, amazing. Well, that just is evidence of a very smart mind. I asked this before. Sorry that I kind of missed that. It's the second time I make this mistake. I absolutely know that they are not connected, but for whatever reason it didn't click. So now we pull one to ground. Now it's off. And now with the next clock, it should read that in as the input. It did it. It read it. Turned off. Then we disable the input again. And this is the output that just shows whatever is stored in here. So we can... Let's turn that LED on again. Oh my gosh. I did a short circuit. Did you hear it clicking? Oh fuck. That chip got hot. That chip got hot. I just want to say watch out. I'm sorry. Oh goddamn, hopefully I didn't fry it. It's still hot. It doesn't smell like magic. It doesn't smell like magic smoke yet though. It's still super hot. Why is it so hot? Maybe it's just because it has to drive all these LEDs. Oh, the Norwegian ice cube. Yeah, I asked for a good recommendation where to order it from, but I didn't hear anything. Can you test if it is fried? I guess the test if it's fried is if it still functions as it should function or not. Now this just makes testing worse because we were not even sure if it works all properly. Still not getting hot. Okay, so input is disabled now. Now we output. And we see the LED. Now let's see if it gets hot. Seems all fine. Let's disable the output. Enable the input. And then we give a clock pulse. See? Did you see this? We did one clock pulse, and now the register read the value only when we did the clock pulse. So at least that one register bit works. Actually, I kind of want to buy a FLIR camera to show the heat of the whole place. That would be also good for debugging. We would see if a chip would get hot. I always wanted to buy one, but they were too expensive to just as a joke for fun. But maybe I can justify it now. You could use isopropanol alcohol to speed up evaporation. Poor man's heat. What else should I spend my money on if not a heat camera? I quickly connect the LEDs again just to test all registers one time with like reading and writing, and then that's the end of the stream. Okay. All of them are glowing. So we disable the output. So it's getting not hot right now. Okay, so we disabled the output. Input is also disabled. Let's take it back to the regular clock so we don't have to click it ourselves. And then we can, input, we need to enable the input. We are reading the 0, we are reading the 1. Always on the clock pulse. Do you see this? Now, there it is. Okay, so this one seems to work. This one works. This one works. This one works. This one works. Oh wait, there's something wrong. 3, 2, 1. Wait, 2, 4, 5, 6, 7. Did anybody notice that I don't have 8 LEDs here? I missed to plug in one. The register works. Did I really miss most of the stream again? Oh, hi Nuflo, I'm sorry. Yeah, so it was a 2-hour stream, a bit short stream today. But we got a wire cutter now. A wire stripper, I mean. And we didn't get to use it at all. I just realized. I was going to the store specifically for this. And I realized we didn't even use it today. Thanks for the tip, Toby. Here's a start for the thermographic camera. Thanks. And now I feel obligated to buy one. Thank you very much, Toby. And yeah, thanks so much for hanging out with me. We didn't build any more modules, but we did verify that the register works, and we didn't blow up anything yet. Almost though. And it was a good debugging learning experience. I think we still made good progress. Okay, thanks so much for hanging out with me. Thanks for the bits and for the subscriptions, and see you probably tomorrow. Probably again later in the day tomorrow.